Today is going to be 33-4. We're going to take a look at double angle identities. But we're going to use double angle identities today to prove various identities. So we're going to be focusing on the proving aspect instead of just being able to evaluate. So remember, the way that we derived these is by using the sum and difference identities. So we said this is the sine of theta plus theta, and we were able to derive what the sine of 2 theta is from that. And so we said that these are the identities that we needed to memorize because we need to use them in various aspects of math. Now our first one here says sine of x minus cosine x squared equals 1 minus sine of 2x. I think this one right here might be the side we want to work with. It looks a little bit more complicated. So I'm actually going to FOIL this. So I get sine of x minus cosine x. Sine of x minus cosine x. So multiplying this all through, sine of x times sine of x is sine squared x. And then minus sine x cosine x. And then minus sine x cosine x. And then plus cosine squared x. Well, sine squared x and cosine squared x, that's a Pythagorean identity, and if I add those together, I am going to get 1. Now if I combine like terms here, this is going to give me minus 2 sine of x cosine x. Now this right here, this is that double angle identity, so I'm going to get 1 minus sine of 2x, which is the same as what I have here. Cosine squared x equals 1 plus cosine of 2x over 2. So this side looks like the more complicated side. Now, because this does all equal cosine, I know that there's 3 possibilities for the cosine identity. There's 2 of them have sine in it. Well, since this side only has cosine, I probably don't want to use the 2 that have sine in it. I just want to use the one that has cosine. So I can change this into 1 plus 2 cosine squared x minus 1 all over 2. Well, the 1's cancel out, and the 2's cancel out. There's my answer. Next one, cosine of 2x equals 1 minus tangent squared x over 1 plus tangent squared x. Now this one is a little tricky. I would say that this side is definitely the more complicated, but the issue is this is one thing and this is one thing, but I see a bunch of tangent stuff. So because of that, maybe I need to use some sort of Pythagorean identity to be able to manipulate this. So maybe what if I said 1 minus tangent squared x over, and I believe this is what, secant squared x? Because now I can separate this into 1 over secant squared x minus tangent squared x over secant squared x. Now if I change everything to sines and cosines, this is going to be cosine squared x minus, this will be sine squared x over cosine squared x over 1 over cosine squared x. Now these cosines are going to cancel out, and so that's going to give me cosine squared x minus sine squared x, and that's going to be my double angle identity, which is cosine of 2x, which is going to be my answer. It was fun algebra with that one. This one, this says the cosine of 3x equals 4 cosine cubed x minus 3 cosine x. Well, I have a cosine cubed, and I have a 4 in front of it minus 3 cosine x. Now, even though this side does look more complicated, I think I'm going to use this side. Now, that cosine 3x, I don't know what that is, but I do know a cosine of 2x. And so in this case, maybe I'm going to use a a sum and difference identity to be able to do this. So I'm going to say cosine of x plus 2x. Now my sum and difference identity is going to be cosine x cosine of 2x minus sine of x sine of 2x. Now, using the double angle identity for this and using the double angle identity for this, I'm going to get cosine of x times, let's try 2 cosine squared x minus 1. That's going to be minus sine of x, and this is going to be 2 sine x cosine x. Now, simplifying everything together, I'm now going to have 2 cosine cubed x minus cosine of x, and then I get minus 2 sine squared x cosine x. All I did was just multiply everything together. This I distributed, and then this, because everything's being multiplied, I just multiplied everything together. Now, my answer here, this doesn't have any sign. So I have a sign here. I need to get rid of that. It's sine squared, so I know I have a Pythagorean identity, and so maybe I need to use that Pythagorean identity. So I'm going to have 2 cosine cubed x minus cosine x minus 2 times, and this would be 1 minus cosine squared x. And so now I can multiply that cosine through, and so I get 2 cosine cubed x minus cosine x minus 2 times cosine x minus cosine cubed x. And then now I could distribute this negative 2 through. And so I'm going to get 2 cosine cubed x minus cosine x minus 2 cosine x plus 2 cosine cubed x. And now combine like terms, I get 4 cosine cubed x and then minus 3 cosine x, which is what I was looking for. That was a pretty good one. For this one here, cotangent x minus tangent x. So for this one, probably using either side would work. I don't think that there's an issue using either side. Why not? Let's do this side. So if I use my Pythagorean identity, now because it's cosine or cotangent and tangent, I know that there's sines and cosines there. So that means that using the Pythagorean identity, I don't think it really matters which one I use, but I want sines and cosines there. So if I do cosine squared x minus sine squared x over sine of x cosine x. Now breaking this up, I can say cosine squared x over sine x cosine x minus sine squared x over sine of x cosine x. Now the cosine x's cancel out, so I get cosine x over sine x, minus the sines will cancel out, so I get sine x over cosine x, and then now this will simplify into cotangent x minus tangent x. Now this does conclude our lesson, and so if you guys have any other questions, please leave them in the comments.